This video is the third in a series where we will go through each of the tables on the Chappell Universal Square to explain exactly how to use each line on each of the various rafter tables. In this video, we will explain line number 3 of the Equal Pitch Rafter Table. We hope you enjoy. Line 3 of the Equal Pitch Rafter Tables refers to three aspects of the jack purlins in an equal pitched roof system, as follows. 1. The difference in length of jack purlin per inch of common rafter length. 2. The top cut layout angle of jack purlins over 1. And 3. The sheathing angle offset per inch or unit of 1. These have significance in the roof system in more than one way. 1 being a length ratio, and 2 being angular ratios. Let's begin by defining the first aspect. Case 1. Difference in length of jack purlins per 1 inch of common rafter length. The values specified in line 3 are in direct relation to the included roof angles in the roof plane, and gives us the ratio as to the difference in length of the purlin per inch of common rafter length. Purlins are members that run parallel to the plate and ridge and perpendicular to the common rafters. Jack purlins are those that intersect with a hip or a valley. Because purlins run perpendicular to the common rafters, the spacing is specified from eaves to ridge along the common rafter length. The value given under the corresponding roof pitch is based on the difference, reduction or increase, per inch of common rafter length. Using the example of a 14/12 pitch, we find the value given under 14 to be 0.6508. This is to say that for every inch or unit of 1 along the common rafter length, the jack purlin length changes 0.6508 inches, or in a ratio of 1 to 0.6508. As an example, if we apply this factor to a purlin spacing of 48 inches, we have the following: 48 times 0.6508 is equal to 31.238 inches. The difference in length of each jack purlin spaced at 48 inches will be 31.238 inches. Line 3, Factor 2. The top cut layout of jack purlins over any unit of 1. Case 2. The top cut of jack purlin over 1. In addition to determining the jack purlin lengths, we can also use this factor to determine the angle for the purlin top cut layout. This angle is often referred to as the sheathing angle in standard construction parlance, as it is used to cut the angle of the sheathing into a hip or valley. In this case, we are using the value as an angular ratio that can be applied to the square as follows. In our example, on the third line under 14, we find a factor of 0.6508. The jack purlin top cut angle can be marked on the timber by using 6.508 on the tongue, opposite 10 on the body, and marking along the tongue of the square. If by using 10 as the constant, the square does not cover the timbers, choose any other number on the body and multiply by the factor and use the results on the tongue. Say you want to use 20 on the body, the equation would be 20 times 0.6508 equals 13.016. Line 3, Factor 3. The sheathing angle offset over 1 inch or any unit of 1. Case 3. The sheathing angle offset per 1 inch of sheathing width. The value given on line 3 can also be used as the ratio of the length of the offset per inch of sheathing width. This is useful to determine the increase or reduction of each course of boards or plywood sheathing into the hip or valley. When running boards or plywood perpendicular to the common rafters into the hip or valley, simply multiply the width of the board or plywood by the given factor in the column under the appropriate roof pitch to determine the offset length for each course. Using the same example for a 14/12 pitch, the value on line 3 is 0.6508. For an 8-inch board, the offset length, or the difference in length for each successive course of boards, would be 8 times 0.6508 equals 5.2064 inches. When using boards, it's best to jig up a square to mark the offset angle on the boards. When using plywood or sheet goods, you will want to measure and mark the offset length and then define the cut angle with a chalk line. The offset when using plywood would be 48 times 0.6508 equals 31.238 inches. If the sheathing runs vertical, from plate or eave to ridge, the sheathing offset length can be determined by dividing the width of the sheathing by the value given. For plywood, the offset would be 48 divided by 0.6508 equals 73.755 inches. The underlying kernel of geometry and math required to arrive at the factors as expressed on the Chappell Square are quite complex, to be sure. The beauty of the Chappell Square is that it makes this information present, available, and readily accessible to apply directly to your next challenging roof system, leaving you free to visualize your next project with the assurance that the Chappell Square will have your back. We hope you enjoyed this video and be sure to keep a lookout for more to come. By subscribing, you will be apprised of all upcoming videos in this series.